We think we know water. I mean, we drink it, we swim in it, we are mostly made of it. But what if this stuff we see every day is actually the most uncommon, most extraordinary substance on our entire planet? What if it's a silent architect, quietly building the world as we know it? It's funny, right? We're always looking for something rare and exotic to find a sense of wonder. But what if the most amazing thing in the universe is the very thing that fills our oceans and falls from the sky? Today, we're going to completely change how you see that simple glass of water. So, we're about to pull back the curtain on 7 of water's incredible secrets, the properties that literally make life possible. And trust me, this isn't just a science lesson, this is the blueprint for life on Earth. Okay, first up, we're going to start small, really small. We're going down to the microscopic level to see what makes water the chemical engine for, well, everything that lives. It all kicks off with one simple concept: polarity. Just think of every single water molecule as a tiny little magnet. It's got a positive side and a negative side. This one fact, this tiny detail, is basically the source code for almost all of water's other superpowers. That tiny electrical imbalance in one molecule is so important that you could say it is the chemistry of life. Now, that sounds like a massive overstatement, right? But as you're about to see, it is absolutely true. And here's the first huge payoff of that polarity. Because those water molecules are like little magnets, they are amazing at pulling other things apart, molecule by molecule. They just dissolve them. This is why we call water the universal solvent. So, what's it dissolving? Oh, just the building blocks of life. It dissolves the salts and minerals our nerves need to fire, the sugars that give us energy, and even gases like oxygen that we need to survive. And because it's so good at dissolving all these vital nutrients, water becomes life's ultimate delivery service. It's the blood in your veins, the sap in a tree, the fluid inside every single one of your cells. All of it is just water carrying the stuff life needs to where it needs to go. Okay, but that polarity also gives water a way to literally defy gravity. It's called capillary action. Basically, water molecules love to stick to each other and to other surfaces, which lets them climb straight up through incredibly narrow tubes. You see this everywhere. It's how a giant redwood tree gets a drink all the way to its highest leaves. It's how blood squeezes through the tiniest little vessels in your body. And hey, on a much simpler level, it's why a paper towel works. All right, let's zoom out. We've been looking through a microscope, but now we're going big, planet-sized big. We're about to see how these same properties make water our world's thermostat, shaping our entire climate. So water is basically a giant thermal sponge. It has what scientists call a high heat capacity. What that means is it can soak up a ridiculous amount of heat energy without its own temperature really changing that much. It's like a global shock absorber for heat. And the effects of this are just staggering. Our oceans absorb heat, keeping the planet from having these insane temperature swings. It's the same property that keeps your body temperature locked in right around 98.6 degrees, and it's what keeps a plant's leaves from literally cooking in the afternoon sun. So far, water's been amazing, sure, but it's been logical. Well, now we get to its strangest, most counterintuitive, and honestly, maybe its most important property of all. Get ready for the density anomaly. You see, water breaks a fundamental rule of physics. Pretty much every other substance on Earth gets denser when it freezes. The solid form sinks. Water does the exact opposite. It expands, it gets less dense, and because of that, ice floats. It seems like such a small thing, doesn't it? Ice floats. Who cares? But just for a second, I want you to imagine a world where it didn't. What if ice, like almost everything else, sank to the bottom? Well, if ice sank, our lakes and our oceans would freeze from the bottom up, and that ice would never melt. Year after year, more ice would sink and accumulate until our entire planet became a solid, lifeless ball of ice. The simple fact that ice floats is one of the main reasons our planet can support life at all. There's another wild consequence of all those water molecules loving to stick together. At the surface, they create this strong, connected network. We call this surface tension, and it makes the top of the water act like a thin, stretchy, elastic skin. This skin is literally strong enough for bugs to walk on. It's what pulls falling water into those perfect little spheres we see as raindrops. And crucially for us, it helps soil hold on to moisture, which allows plants to grow. It's another one of these quiet, hidden properties doing incredibly important work. So, what does this all add up to? In our final section, we're going to see that water isn't just the backdrop for life to happen, it's the main character in the story. We have this tendency to think of life as something that happens in water, right? Like it's just the stage where the play of biology unfolds. But that gets it completely backwards. Water isn't the stage, it's an active, absolutely essential ingredient in the play itself. Every single metabolic reaction that is keeping you alive right now is happening in a water-based solution. Photosynthesis, the process that creates the oxygen we breathe, literally works by splitting water molecules. From a tiny seed to a complex cell, nothing works without it. And that really brings us to the most fundamental truth of all. There are no exceptions to this rule, no workarounds. When we search for life on other planets, what's the very first thing we look for? Water. Because the equation is absolute. No water, no life, period. So water isn't just some resource. It's the silent architect that designed and built our living world, right from the molecule up. And that leaves us with one last really important question to think about. If water is life's blueprint, what are we doing to protect it?